so good afternoon guys. So today we're going to discuss about the integral domains, or somehow we can refer to this as the abstract algebra. So let's define first what is an integral domain. In mathematics, specifically abstract algebra, when we talk about integral domain, it is a non-zero commutative ring in which the product of any two non-zero element is non-zero. So it might be technical on the definition and what do we mean by these things. So today we're going to discuss what an integral domain is. So this equation has two solutions, 2 and -2, right? So this seems straightforward, right? But you have to solve this equation, we have to use a big assumption that if the product of two terms is 0, then one of the term must be 0. Okay? In abstract algebra, this isn't always true. Okay, so let's go on with the integral domains. Let's see an example where this technique of solving equation does not work. We're going to solve x squared plus 5x plus 6 is equals to 0. In the integers mod 12, in the integers, let's say mod 12. So if we factor the left hand side, we get x plus 2 multiplied by x plus 3, which is congruent to 0 mod 12, isn't it? So again, I just set the mode configuration here as 12. So we have to think what should be the value of x so that this 0 mod 12 should satisfy. So if we see each term, let's say for example, x plus 2 is equals to 0 term, what should be the value of x so that once we perform 0 mod 12, the output will be the same. So we're expecting value 12 here. So therefore, the value of x here, the value of x to have a 0 mod 12 output should be equal to 10. Okay? Because 10 plus 2 is just the same as 0 mod 12. 0 mod 12 is basically 12. Okay? Then, for the other term, x plus 3 is equals to 0 mod 12. Okay? In this part, for it to become 0 mod 12, x should be equal to 9. Okay? So you get x equals to 10 or x equals to 10. So are all the solution? So since there are only 12 numbers in the ring on an integer mod 12, let's go ahead and check all the possible combinations. So if we go ahead and check all the possibilities, we will plug in zeros through 11 into the polynomial value. What do I mean by this? So if we're going to plug in x squared plus 5x plus 6 is equals to 0, just like in the given equation, mod 12, again, if we're going to refer to a mod 12 condition, so the term will be on the left hand, x plus 2 times x plus 3 is equals to 0 mod 12. So if we're going to substitute values here, if x is equals to 0, 0 plus 2 times 0 plus 3 value is equals to what? So again, we're referring to, this equation, x squared. So 0 squared plus 5 multiplied by 0 plus 6 is equals to 6. Okay, and then if x is equals to 1, okay, 1 squared, okay, 1 plus 5 multiplied by 1 plus 6, the value here is equals to what? 12 mod 12, isn't it? So 1 plus 5 multiplied by 1, 6, plus 6 is equals to 12. 12 modulo 12 is equals to what? 0. Okay, so we don't have any modulus there. Okay, so if we're going to plug in 2, so that will become 2 squared plus 5 multiplied by 2 plus 6. So we have here the value 4 plus 10 plus 6 is equals to 20 mod 12, which we're going to have the result of 8. Okay, then for 3, so we have 3 squared plus 5 multiplied by 3 plus 6. So we're going to have here 9 plus 15 plus 6, which is 30 mod 12. So the remainder here will become 6. Okay, so if we were going to fill in all these value of x in our equation, so we will come up with this kind of table. Okay, so if we fill out the table for the remaining numbers, we can easily see that on the given solutions, we can see that the equation has not 2 solutions but 4 solutions. Okay, we have here solutions 1, 6, 9, and 10 for our term to be equal to 0. But in factoring, again, if we're going to recall, x squared plus 5x plus 6 is equals to 0, let's say mod 12, so the factor will become x plus 2 times x plus 3 is equals to 0 mod 12. So the term will become what? X plus 2 is equals to 0 mod 12. Therefore, x should be 10. Then x plus 3 is equals to 0 mod 12. So the value of x should equals to be what? 9. Isn't it? But we didn't find that values here. Okay, but we have here 4 solutions. Okay, solution 1 for 1, 6, 9, and 10. So what went wrong? So to see the problem, let's take a closer look on the term. So after the factoring, we have x plus 2 times x plus 3 is congruent to again setting two solution. Again, setting each term to 0 gave us two of these solutions, 9 and 10, right? So why do we miss the other two? What kaya? Why we don't have like 6 and 1? So let's consider it again. So if we're going to analyze this solution, okay, again we're missing 2. To see why, what looks happen when you plug in 1. So x equals to 1 will give us the equation 3 times 4. Again, we're using this equation. Is equals to 0 mod 12. And if we plug in 6, okay, again, we're missing this 1 and then 6. If we plug in 6, x equals to 6. So we have here 6 plus 2 is 8 times 6 plus 3 is 9 equals to 0 mod 12, which is also like 0 mod 12, right? 72. So working mod 12, it's possible to multiply two non-zeros value, okay, together, and then we get 0. Okay, so let's say for example 2 times 6 is equals to 0 mod 12, and then 3 times 4 is equals to 0 mod 12, isn't it? So we say the integers mod 12 at 12 0, so or 0 divisors. Okay, so we now see the culprit. Working mod 12, it's possible to multiply two non-zero numbers together and then we get zeros. Again, we say that the integers mod 12 has 0 divisors. And if the 0 divisors makes our solving equations more difficult. With real and complex number, this doesn't happen. These fields do not have 0 divisors. That's why in regular algebra, you learn to solve many equations by factoring since elementary and setting the terms to 0. But in abstract algebra, again, this technique is not good enough. So I'd like to take a moment and talk about the term 0 divisors. Okay, so let me explain 0 divisors. This name was chosen because division can be defined in terms of multiplications. They are correlated, isn't it? Okay. So, for example, when working with an integers, we say b divides a. Let's say b divides a if b dot c is equals to a for some c. So let me write it again clearly. So for 0 divisor, in the integer, let's say this is represented as the symbol for 0 divisor. Okay. B divide A if B times C is equals to A for some C. So from this definition, the term 0 divisor makes sense. Okay. Actually, in the integer mod 12, 3 times 4 is equals to 0 mod 12. So 3, 0 divisor mod 12, and 4, 0 divisor mod 12 can be considered. Okay, they are really are what we call as 0 divisor. Okay, so let's return to the equation x squared plus 5x plus 6 is equals to 0. Except this time, we're going to mark mod 11 instead of mark 12. So the integers mod 11, 0 divisor is 11 or mod 11 have no 0 divisors. This is because 11 is a prime number. So the only way that the product of two number is a multiple of 11 is that, again, I can write it as 11 a times b only if 11 0 divisor a or 11 0 divisor b. So this is only like a product of 11 if one of the number is divisible by 11 and 9 of the integers 1 to 10 is a multiple of 11. So this ring does not have any zeros number. Okay, so before we can factor left hand side, which is x plus 2 times x plus 3 in the equation x squared plus 5x plus 6 is equals to 0 mod 11. Okay, then this one is 0 mod 11. So before we factor, the left hand side is congruent to 0 mod 11. Setting each term to 0 will give us what value? Again, so we have the value of, what should be the value of x here? That we could have mod 11. So we could have here the value as 9. Then x plus 3 is equals to 0 mod 11. So what should be the value of x here? 8. So it will give us x is equals to 9 and x is equals to 8. Let's see if there's any other solution by plugging in all the other integers in mod 11. So let's consider the table again. When x is equals to 0, and then our equation is x squared plus 5x plus 6 mod 11. So gagawin lang natin is we're going to substitute it here. So 0 squared plus 5 times 0 plus 6 is equals to what? 6. Right? Mod 11. So the value is what? 6. Plug in x is equals to 1 will give us what? So 1 squared, 1 plus 5. So 6 plus 6 is equals to 12 mod 11, which is what? 1. What about the value of 2? So 2 squared, 4 plus 5 times 2 is 10, 14 plus 6, 20 mod 11. So what is the value? 9. Okay, so if we're going to fill out the rest of the table for 3, we have here 8, then 4. If we will just continue, right? Okay, and then I'll just continue on this part. So the value for 5 is equals to 1, 6 is equals to 6, 7 is equals to 2, and then 8 is equals to 0, 9 is equals to 0 value, and then for 10 we have here 2. So therefore we have here the factor 9, 8 and 9. So that it doesn't have life. It's included in the ring, that's why it satisfies the given conditions, no? 8 and 9, and like the first example. So the prime number will satisfy this analysis. So when a ring R doesn't have zero divisor, so it therefore it can solve equations by factoring and setting terms to 0. So doing the technique, factoring setting the terms to 0 does work. So for there's a reason, there's a term for such ring which is called as the integral domain. So integral domain is a commutative ring with a multiplicative identity 1. Okay, so commutative ring with a multiplicative identity of 1 and no zero divisors. And a natural question is, why do we require an integral domain to be what? Commutative. Why our integral domain has to be commutative? After all, it seems that the most important things, at least for solving equations, is there are no zero divisors. One reason is why when the idea of an integral domain was developed, much of the focus was on generalizing the integers for use in numbers theory. Hence, the word integral in integral domain. And there is, however, a term for an arbitrary ring with no zero divisors, which is called as the domain. So even if we solve that, the factor of that, there is no zero divisors. So that we what we call that's the integral domain. So it is a domain, but you encounter integral domains more frequently. So integral domains have another useful property, which is, first, let's start with the cancellation policy. Suppose we have to find the solution, for example, 2x is equals to 6y. Your instinct might be to first simplify this. So again, we're supposed to want to find the solution, the equation x plus 6y. So our instinct might be the first to simplify this by dividing both sides by 2, isn't it? So if we divide both sides by 2, we can come up for the equation x is equals to 3y. But when working with a ring, you may not be able to divide. So a different approach would be a factor to both sides, then cancel the 2s. How come it would be possible? So we could just have to factor out 2, then 3y. So we can cancel this, right? And then, so therefore we have x is equals to 3y. So give you 3y. Factoring and cancelling does not require division, but you can safely cancel in any ring? Unfortunately, no. So if we look on the equation, 3x is equals to 6y. Again, let's use mod 12 again. So in the integer ring mod 12, this equation has a multiple solutions, right? But the one solution is x is equals to 6 and y is equals to 1, right? To satisfy it. I can write x is equals to 6, y is equals to 1. This is because 18 is congruent to, again, 18 is congruent to 6. 6 mod 12. Right? So let's see, no? Let's check. 3x equals to 6y mod 12. So 3 times 6. Again, if the value of x equals to 6. And then 6 times 1 mod 12. So 18. 6 mod 12. But look what happens if we factor out 3 then cancel. What will happen? So we have, again, if we're going to use the cancellation method, x is equals to 2y mod 12. Now if we plug in 6 as equals to x and y is equals to 1, so we have here 2 times 1 mod 12, which is what? False. 2 times 1 is 2. Mod 12 is equals to 2, not 6. Right? So in the original equation, 6 and 1 is a solution, but not after the cancelling. It is not. So when you can cancel safely in integral domain, so to find out, supposedly, a times x is equals to a times y. In some ring R, and a is not 0. So if we get everything on the one side, we can factor out a using the distributive property. So a times x minus a times y is equals to 0. So a factor x minus y is equals to 0. There are no zero divisors. So we can say that x minus y is equals to 0. This implies x is equals to y. So the another benefit of an integral domain is the cancellation property. So to recap, an integral domain is a commutative ring or with one that has no zero divisors. The absence of zero divisors means you can use the cancellation properties. It also means that you can solve an equation by factoring and setting the terms to 0. Here's a puzzle to discuss. How many quadratic equations are there in mod 12? And do any of them have just two solutions? Okay? So, with today's topic, we have discussed what's in integral domain and the functions, how to use the cancellation domain. So for your asynchronous activity, I want you to analyze again integral domains and find out problems which use integral domains and solutions. Okay? So, again, with your assignment for asynchronous activity, analyze and evaluate again what is an integral domain. Okay? So after that, you have to give at least 3 problems solved using integral domain and then explain in a short video how it was solved. It's like what I do today. Okay? So if you have any question, just don't hesitate to message me or send me some message to our FB group or into our Google Classroom. So that's it for now. Thank you and see you next time. That is us on.